Good afternoon, everyone. I am Anirudh Biswas, and today we will talk about Maxwell equation. Before starting, I would just like to say that I would give half of the lecture in English and try to give the other half in Hindi for demonstration purposes. Now let's begin. Okay, so what is Maxwell equation? You see, in electrodynamics, Maxwell equations are the set of these four equations which holds a crucial value. So this equation, what it does is that it provides you the information about the electric field and magnetic field, means their distribution corresponding to the given charge density and current density. Now, a brief overview of this equation shows that I have written some of the values in blue color and some of the values in red color. So now the values in blue color, these are the source term. So here, as I mentioned, this is charge density, so it is acting as a source. And similarly, this nu naught J, this is current density, which is again a source. So and on the left hand side you see divergence of electric field, curl of electric field, divergence of magnetic field, and curl of magnetic field. I have also written some of the part in a red color, as I mentioned. This part is basically the change in field term with respect to time. So you see there is a minus del B by del T, and there is 1 by C square del E by del T. One question, it is one thing which one may ask is that I have additionally written 0 here, means it does not make sense, right? Why to add a 0? Because you add any number with 0, it will give you that number. The point is, this 0 here I have written to emphasize that you get the 0 vector in the case of electrostatics. And when you consider the time varying magnetic field, then only you get this contribution. Otherwise, this contribution is 0. So now, this was a brief introduction and overview of this Maxwell equation. So now, let's start discussing this equation. So I will start with the first equation. So the first equation reads that divergence of electric field is equal to rho by epsilon naught. So, before discussing, we have to understand what is divergence. So, divergence in simple layman terms is the net flux through a particular closed surface. So, if you are confused or if you want to recall, then what is flux? Flux is basically like this. You have a surface and there are some some field lines, not necessarily electric field, but anyway there are some field lines, and there are some field lines which are exiting this. In real case scenario, it won't happen that 3 lines are coming and 4 lines are going, but this is just for illustrative purposes. The point is that overall this flux relates to the number of lines which are exiting. So in this case, for the divergence case, we will take a closed surface. Why closed surface? For example, a spherical case. Yeah. Now you will see why I have chosen closed surface. Actually, what happens that in the derivation part, you will see that you require some Gauss divergence integral term, and corresponding to that you require closed surface. So whatever the point is that suppose now I take a point charge and I place it beyond this closed surface here. So now everyone have read that the point charge liberates the electric field in a radially outward fashion. So like this. Some lines will of course pass through this. Yeah. Now see, you see there are 4 electric field lines which are entering in this region, which is not considering the charge, means it is not containing the charge, and exactly 4 lines are exiting this charge. So more or less in this case the net flux, this left hand side, is equal to 0. On the right hand side we can also verify the same. Let's check whether this equation holds or not. So in the right hand side we have charge density. More or less, just to compare, the charge density is directly proportional to the charge itself. So the point is that I took a charge q here, let's say positive charge. When you will write it in the integral form, you will get the positive charge in place of rho. But since I am writing in differential terms, so that's not an issue. The point is that there is no net charge enclosed, net charge in this closed shape, in this closed sphere. There is no net charge which is residing inside this. So there is no net charge. So that means the net charge density enclosed is 0. So that means 0 is equal to 0. So 0 is equal to 0. This equation satisfies when the charge is kept outside this closed surface. Now let's put the charge inside and see what's happened. So I will again draw the diagram just for the sake of simplicity. Yeah. So this is our spherical surface. Now let's put the charge inside and see what's happened. So I will put the charge here. Now again I will simply draw the electric field vectors. Now see that there are no incoming electric field lines here. All the electric field lines are pointing outwards direction. So more or less net input electric field lines are 0, whereas there are some non-zero positive outward electric field lines which are going out of this surface, right? This. So the concept is, we do not need to calculate, just try to understand. The concept is that the net divergence of electric field in this case will be a non-zero term. Whatever that term, we will see it later. That is the point. Now on the right hand side, this is also justified because there is a charge here, right? So there, if there is a charge, that means more or less it has some charge density. So the concept is that on the right hand side also it is non-zero, positive, non-zero, positive because we took the charge to be positive. So that's why there is a positive charge density. So basically in this case also some positive non-zero value, say non-zero value A, positive A is equal to some again positive A. A is just a constant, whatever value it holds. Okay. So the I guess and I hope that you understand the first equation, right? The first equation, to summarize, just tells you about the net flux passing through a closed surface. In the integral form, you can, as I mentioned earlier, I will just write. In the integral form, you will write closed integral. This is a very important thing. Closed integral of this. So this is, if I have not written this closed part, this is like an open surface, any surface. When I use this represents the closed part. So this for example a balloon or any other sphere, globe, anything like that, a closed surface, that is equal to charge enclosed. Actually, to be more precise, I should have written here enclosed, Q enclosed. So charge enclosed divided by epsilon. So I hope the first equation is clear, right? Now let's talk about the second equation, that is divergence of B is equal to 0. So B here means magnetic field. What it shows that unlike electric field, we will always have magnetic field such that its divergence always goes to 0. That means in this type of scenario, if I take some surface, we will never have something like 3 lines are incoming and 4 lines are outgoing. So there is never a net flux. Why is that? Because physically we can see, if you search in the internet or go through some books, physically we do not see any monopole in our day-to-day life. In our nature we have never observed monopole. So there is basically positive charge, isolated positive charge or negative charge in the universe, that is okay, but there is no there is no north pole only and or south pole in the universe. If you even break a magnet, it again splits into north pole and south pole, but it will never happen that you break a magnet and there is only north pole and only south pole. So this basically shows that there is no monopole. The third term is curl of E is equal to 0 for electrostatic case and minus del beta by del t, that is derivative with respect of time of this magnetic field. So if let's check the case of electrostatic case where there is no magnetic field. In that case this value is 0. So first let's try to imagine what is curl. What do you even mean by curl of a field? So curl basically says how much a field twist or basically rotate about a particular point. So that means, for example, there is a river like this and there is some sort of, you see there are some sort of eddies in the river. Sometimes this happens. So for this region the curl is 0. This line is not rotating with respect to anything, but there is a sort of center point in this case where it is basically rotating or twisting, curling, whatever you want to say. So curl basically tells you the magnitude with which magnitude and the direction of the rotation of that field. So the simple thing is that in the case of electrostatics this term comes to be a 0 vector. Now we can again check this through the charge, the point charge. In the concept of point charge, again we see radially outward direction electric fields, whatever. You see there is no concept of curling or twisting, right? There is nothing like that. This is wrong. This is correct. Means only we have radially outward or radially inward electric fields. So there is no twisting concept. So in electrostatics you will never find an electric field which has a non-zero curl. If someone provides you something like that there is an electric field like this due to some charged conductor or whatever, then he or she is giving you the wrong information. That only happens when the magnetic field changes with time. If time permits, we will actually go through that. Now, the fourth equation is curl of B is equal to a source term. What is that source term? As I mentioned, that is that is current density. And again there is a change in field term, that is now because of the electric field. So again this shows that a curling effect in the magnetic field is generated because of these two things. Now I have justified well using point charge these two equations, right? Let's take an example of a infinitely long current carrying wire. In infinitely long current carrying wire, what happens is that if you have read about the basic electrodynamics course, if you have taken basic electrodynamics course, then what happens is that a magnetic field like this is produced. This is your magnetic field, B field. So you see, in layman terms, I can see that it is twisting or rotating about a center point, whatever that point is. So basically, this happens just because of a J, that is current density. Current density is basically current passing through some area. So that is this. So whenever a current flows through a wire, a magnetic field is generated. such that its curl is non-zero and it is dependent upon that amplitude of current, current density. And again, there is another concept of the time varying electric field as well. If time permit, we will talk about that. Now, to summarize, one thing I would like to add is that you see the first and the third equation, these two equations comes from Coulomb's law. You can directly derive these two equations, this part, not this part, just forget about this part. You can directly derive these two equations from Coulomb law, which states that you have already learned, right, in your 11th and 12th, that is k q1 q2 upon r vector square, where r is the relative distance between 2 points. So I hope right now this is clear, right? If you have any doubt, you can always ask me. Now let's talk about the second and the fourth part, these two parts. Similar to Coulomb's law, there is another law for the magnetic field by which you can directly get this curl and divergence of magnetic field. And what is that? That is Biot-Savart law. These are the basic laws which were further modified by Maxwell and others to give this complete equations of the electrodynamics. So from the Biot-Savart law, again, you will never get the red term, this term, but you will get these blue terms, these source terms. So this part of the equation you will get from the Biot-Savart law. Now we talked about the electric field, the curl of electric field, the divergence of electric field. Now we will see, if time permits, that is, we will see how these equations are actually derived. So now I will switch to Hindi for demonstration purposes only. So अभी तक हम लोगों ने ये किया, अभी हम लोग सबसे पहले इस इक्वेशन को डिराइव करके देखते हैं. सो ये इक्वेशन मैंने जैसे प्रॉमिस किया आप लोगों को कि कूलॉम्स लॉ से ये डिराइव होता है, तो हम देखते हैं. इसके लिए क्या करना है, सिंपली मान लीजिए कूलॉम्स लॉ जाहिर सी बात है दो चार्ज के बीच में ही होगा. तो ये हमारा कोऑर्डिनेट एक्सिस है और यहाँ पे मान लीजिए मेरा एक चार्ज है, यहाँ पे है, और दूसरा चार्ज यहाँ पे है. इन दोनों के बीच का जो डिस्टेंस है, इसको मैं अगर मैं यहाँ पे पोजीशन वेक्टर डालता हूँ, दिस इज चार्ज Q1, दिस इज चार्ज Q2, तो फिर इन दोनों का जो मैग्नीट्यूड है, ऑल्दो दिस इज स्क्रिप्ट R से डिनोट करते हैं, बट मैंने जब एक चार्ज को ओरिजिन में रख दिया तो ओरिजिन के रेस्पेक्ट में हम लोग डायरेक्टली डिस्टेंस कंसीडर कर रहे हैं, तो मुझे दो अलग अलग वेक्टर लेके उनका सब्ट्रैक्ट करके ये सब अननेसेसरी चीज करने की जरूरत नहीं. तो आई विल जस्ट राइट इट एज R, सिंपल R वेक्टर टू बी मोर प्रिसाइज. सो फर्स्ट इक्वेशन क्या कहता है कि इट टेल्स यू अबाउट तुम्हारा जो ये है फ्लक्स है. तो हम लोग इस इक्वेशन को कैलकुलेट करके देखते हैं. नाउ closed integral of electric field. Electric field is what? KQ. Electric field is basically force per unit charge. So it will be like only 1Q. ठीक है. यहाँ पे हम लोगों ने क्या किया, यहाँ पे R स्क्वायर किया, और हम लोगों को पता है पॉइंट चार्ज की वजह से हमेशा रेडियली आउटवर्ड डायरेक्शन में लगता है, तो देयर इज यहाँ पे हमें एक R कैप डालना पड़ेगा. अब इसका डॉट प्रोडक्ट करेंगे सरफेस वेक्टर के लिए. तो सरफेस वेक्टर हम लोग क्या चूज करेंगे कि मान लीजिए हम लोगों ने ये हम लोगों का ये है एक क्लोज सरफेस है, हम लोग इसके लिए गॉस लॉ हम लोग कैलकुलेट करके देख रहे हैं. तो फिर हम लोगों का एक चार्ज जो है वो यहाँ पे रहा और एक चार्ज जो है वो से इस डिस्टेंस पे रहा, और हम लोग इस डिस्टेंस पे तुम्हारा गॉस लॉ कैलकुलेट करके देख रहे हैं. तो पॉइंट है कि यहाँ से यहाँ पर डिस्टेंस R हो गया और वही कोऑर्डिनेट एक्सेस बनाया. ये सरफेस जो सरफेस वेक्टर निकालने के लिए हम इसको कार्टेशियन में भी लिख सकते हैं नहीं तो हम इसको स्फेरिकल में भी लिख सकते हैं, बट स्फेरिकल में लिखना यहाँ पे ज्यादा प्रिफरेबल है क्योंकि कार्टेशियन में एक्स वाई जेड तीनों कंपोनेंट रहेंगे, काफी कंफ्यूजन होगा। तो हम लोग क्या करते हैं, यहाँ पे स्फेरिकल लिखते हैं। तो स्फेरिकल का जैकोबियन एक रहेगा आर स्क्वायर साइन थीटा डी थीटा डी फाई क्यू, क्योंकि एक कांस्टेंट रेडियस में, रेडियस तो चेंज नहीं हो रहा, कांस्टेंट रेडियस में यहाँ पे आपका थीटा और आपका फाई जो है ये आपका थीटा है, ये आपका थीटा है, और ये वाला जो है ये आपका फाई है। ये दोनों के कॉरेस्पॉन्डिंग आपको एक पर्टिकुलर रेडियस में पूरा स्फीयर मिलेगा। तो ये हो गया। इसी को जब हम कैलकुलेट करते हैं और ये होगा हमारा आर कैप। तो आर कैप के साथ आर कैप डॉट प्रोडक्ट 1 हुआ और यूनिट वेक्टर है, आर स्क्वायर से आर स्क्वायर कैंसिल हो कर सकते हैं। इसी चीज को इसको थोड़ा खोल के देखते हैं तो ये हमारा बनेगा 0 से पाई फॉर थीटा एंड 0 से 2 पाई फॉर फाई। तो ये बन गया हमारा साइन थीटा, ये बन गया हमारा डी थीटा डी फाई, ये हो गया हमारा के को हम लोग लिख सकते हैं 1/4 पाई एप्सिलॉन नॉट, क्यू हमारा बाहर रह गया। ठीक है, तो यहां से इस इंटीग्रल में हम लोग अगर इसका इंटीग्रेशन करेंगे तो साइन थीटा का इंटीग्रेशन होगा माइनस कॉस थीटा। सब कुछ काट पीट के कैलकुलेशन करके देखेंगे तो इस इतनी वैल्यू आपकी 4 पाई के बराबर आएगी। सो Q डिवाइडेड बाई 4 पाई एप्सिलॉन नॉट इंटू ये इंटीग्रेशन का 4 पाई, ये दोनों कैंसिल होंगे और आपको मिलेगा Q बाई एप्सिलॉन नॉट। सो अभी तो यहाँ पे बोर्ड में लिखने की बहुत अच्छी जगह नहीं है बची, बट स्टिल बेसिक आइडिया ये है कि आपका फ्लक्स जो है वो बराबर Q बाई एप्सिलॉन नॉट, ये आपका प्रूफ हो गया। अब कर्ल के बारे में बात करें, अब यहाँ पे बहुत ज्यादा जगह नहीं तो चलो मैं यहाँ पे लिख रहा हूँ, आई होप आप लोग देख पा रहे हैं सब लोग लास्ट तक। ठीक है, तो यहाँ पे कर्ल के बारे में बात करते हैं। तो कर्ल कैसे निकालेंगे, आप कुछ मत कीजिए, आप इसका इंटीग्रेशन कर दीजिए। आप एक इंटीग्रल कैलकुलेट कर रहे हैं ई वेक्टर डॉट डीएल वेक्टर। जब आप इसका इंटीग्रल, अभी डीएल वेक्टर इन जनरल क्या है, लेंथ वेक्टर जो है वो हम लोग कैसे लिख सकते हैं, वो हम लोग लिखते हैं डी आर आर कैप प्लस आर साइन थीटा थीटा कैप प्लस आर स्क्वायर साइन थीटा डी फाई फाई कैप, और यहाँ पे डी थीटा कैप होगा वट एवर। सो बेसिकली, और इलेक्ट्रिक फील्ड आपका रेडियली आउटवर्ड डायरेक्शन होगा। तो इन दोनों का जब डॉट प्रोडक्ट होगा तो केवल आपका डी आर वाला टर्म ही बच जाएगा। तो इंटीग्रल जब आप इसका कैलकुलेट करेंगे तो के क्यू बाई आर स्क्वायर, इसका इंटीग्रल डी आर के साथ करेंगे तो फिर और अगर आप इसका लिमिट a से b किसी पे रखते हैं तो इसका वैल्यू कुछ आएगा आपको के क्यू 1/r a माइनस 1/rb। अगर a और b ये दोनों पॉइंट सेम हुए, दैट इज यू आर कंसिडरिंग अ क्लोज्ड इंटीग्रल, उस केस में ये वैल्यू वैनिश हो जाएगी। तो आपको मिल जाएगा बेसिकली ई डॉट डी आर इज इक्वल टू 0। तो क्लोज्ड इंटीग्रल 0 हो गया। अब इस चीज को आप सब लोगों ने मतलब ये स्टोक्स लॉ तो पढ़ा ही होगा, तो इसी को हम लोग स्टोक्स लॉ में कैसे लिख सकते हैं, कर्ल ऑफ द वेक्टर दिस वेक्टर डॉट ds, जितना भी आपका एरिया वेक्टर है, दैट इज इक्वल टू 0। अगर हम LHS और RHS को कंपेयर करें तो कर्ल ऑफ E इज इक्वल टू 0 आ जाता है। सिमिलरली हम मैग्नेटिक फील्ड्स के लिए भी निकाल सकते हैं। मैं एक सेकंड टाइम देख लेता हूं, टाइम कितना हो गया, ओके। सो अभी के लिए इतना ही करते हैं, काफी ज्यादा कर दिया है। अभी के लिए फिलहाल इतना करते हैं, नेक्स्ट क्लास में हम बाकी डेरिवेशन देखेंगे। ओके, थैंक यू।